Hello kids, welcome to today's chemistry lesson, Chemical Formulae and Equations, page numbers 38 to 41. Now let's identify the objectives of this lesson. They are understanding chemical formulae, learning to write chemical equations, learning the types of chemical equations, learning to balance chemical equations, and understanding state symbols. First, let's try to understand what a chemical formula is. The chemical formula can be defined as the symbolic representation of the chemical composition of a compound. For example, H2O. H2O is the chemical formula for water. It clearly shows that the compound water contains the elements hydrogen and oxygen. It further indicates the number of each element present in a compound. So according to this example, the number of hydrogen atoms in a molecule of water is 2 and the number of oxygen atoms in a molecule of water is 1. Here are some other examples of chemical formula of different compounds such as CO2 for carbon dioxide, NH3 for ammonia, and NaCl for sodium chloride, HCl for hydrochloric acid, CaCO3 for calcium carbonate. Then let's see what a chemical equation is. Chemical equations are the symbolic representations of chemical reactions. Here the reactants are written on the left side while the products are written on the right side of the equation. For instance, look at the chemical equation given here. It is the reaction between nitrogen gas and hydrogen gas to produce ammonia. So in this equation, the reactants nitrogen and hydrogen are written on the left side, whereas the product of ammonia is written on the right side. Then let's understand the chemical equation in detail. The symbols in a chemical reaction represent the element in each compound, and the small numbers or the subscript that are written slightly lower on the line represents the number of atoms of each element. Lastly, the arrow which separates the reactants from products is read as yields. Now in this example, we can see the chemical equations for the reactions between hydrogen and oxygen to produce water. Here the symbols represent the elements and the subscripts represent the number of atoms of each element. Further, the reactants and the products are separated by the arrow. Now let's identify the types of chemical equations. They are number 1, word equations. So the example is sodium plus chlorine yields sodium chloride. It is written using the names of the reactants and the products. Then the second type of chemical equation is symbol equations, which are generally referred to as chemical equation. So according to the example, a symbol equation is written as sodium plus chloride yields 2NaCl. Na plus Cl2 yields 2NaCl. Now let's see how to balance these chemical equations. First, let's identify the steps to balance an equation. In order to balance any given chemical equation, we need to count and write down number of atoms of each element that is present on the reactant sides and the product side. Then we must work across the equation from left to right and balance the number of atoms of each element on both sides by using coefficients. Then at the end of balancing, we need to check again and make sure it's properly balanced. Okay. Now that we know the steps, let's try to balance this equation for the reaction between H2 and O2 to produce H2O. First, let's count and write down the number of atoms of each element represents on the reactant sides. So the number of hydrogen atoms is 2 and the number of oxygen atoms is 2. Then let's count and write down the number of atoms of each element present on the product side. Here the number of hydrogen atoms is 2 and the number of oxygen atoms is 1. Now if we compare the number of atoms on both sides, we can see that the number of oxygen atoms is not balanced because there are 2 oxygen atoms on reactant sides and there is only 1 oxygen atoms on the product side. So in order to balance the oxygen atoms, we can multiply the number of oxygen atoms by 2. Now make sure to multiply the number of hydrogen atoms of the products by 2 as well. This is because both hydrogen atoms and oxygen atoms are present in the same compound in the product side. Now if you observe closely, you will notice that even though the number of oxygen atoms on both sides are balanced, the number of hydrogen atoms are not balanced. So in order to balance the hydrogen atoms, we can multiply the number of hydrogen atoms on the reactant side by 2. Then let's count and see. Now the number of hydrogen atoms in both sides is 4 and the number of oxygen atoms on both sides is 2. Now we can say that we balanced this equation. Therefore the balanced chemical equation is written as 2H2 plus O2 yields 2H2O. So now I hope you understood how to balance chemical equations. Then let's try understand what state symbols are. State symbols are used to show the physical state of a substance in an equation. The state symbols are S for solids, L for liquids, G for gases, and AQ for aqueous solutions. Now let's see how to use the state symbols. In a chemical equation, the state symbols are written in simple letters inside brackets on the right side of each substance involved in the reaction. Hence, according to example mentioned here, we can identify sulfur as a solid, oxygen as a gas, and sulfur dioxide as a gas. Now kids, I hope you found this lesson useful. Good luck and thank you for watching.